Hello and welcome. In this video, we're going to look at how to calculate RMS voltage, peak-to-peak voltage, and average voltage. We need this when we're looking at our oscilloscopes because a lot of times we'll end up with measuring the peak voltage and then we'll need to calculate out the other ones. And also our multimeters will measure RMS voltage. And so sometimes to correlate our readings, we'll need to convert between the two here. So a sine wave has a peak value of 28 volts. Determine the following values. It says RMS, that's root mean squared. So that's kind of like an average over time, but it's usually falls a little bit higher than our average. You can see it down here, root mean squared, means that when we take this one, it's what our multimeter reads, and it usually gets a little bit higher than what our actual average voltage is for the circuit. They're calculated differently. Right. We also have our peak to peak over here. That's that VPP, and that's from the very, very top of our waveform to the very, very bottom of the waveform. And so that's going to be 2 times our peak voltage, right? Because the rise and the fall of our waveform should be equivalent to each other. That's what we expect with a perfect sine wave. And so that's what we're going to work with. So we'll say that our RMS voltage is equal to our 0.707 value multiplied by our VP value. We know what our VP value is. This 0.707 is actually derived in the back of the book. It is a derivative for our sine wave, and it kind of details what our sine wave is doing in a predictive pattern. And so if you want more about that, you can find that in the appendices in the back. So we're going to calculate this out. We know our peak voltage is 28, and we know that we can just calculate that by multiplying by our 0.707 here. So we'll say that we have 28 times 0.707, and that gives us 19.796, and we can round that up. We can say that we have 19.8 volts RMS. So if we were to read a sine wave across a component that has 28 volts peak on it, then we should see that our multimeter reads a VRMS value of 19.8 volts. So that's kind of the goal here, is to be able to correlate our values together to see if our readings match. Okay, so peak to peak is the rise and fall, right? It's the second one here, the rise and fall of our waveform. And so we expect that to be 2 times our peak value. So we'll say 2 times VP. We know what our peak value is, so we can just multiply that by 2 and get that out. We'll say 28 times 2, 56. So 56 volts. It's not a 6. Volts, peak to peak. PP at the end there. And make sure you signify what value you're working with. Because most of the times, if we're just talking about voltage, we're going to end up talking about VRMS. And so if you start talking about peak to peak voltage or even peak voltage, then you need to tell us that that is what you're working with, right? Okay, and it's easier to keep your equations separated when you do that anyway. This last one here is an average voltage, and it correlates with the cycle of our circle and how we perceive our sine wave as a circle rotation. And so that is also calculated in the back of the book if you want more, but it reduces down to 2 over pi times our peak voltage VP. And so we'll send this out and we'll do one more here. We'll say that we have 2 over pi, and I'll show you something here over our pi value. So that means you can type in this here. You can say that it's also equal to 0.637 times VP, right? Because that's what we got over here is 0.637 when we put 2 over pi in. And so sometimes the textbook will go back and forth between those two. Just know that they are actually using 2 over pi. And if you need a higher level of accuracy, you might want to keep your pi in there, right? Because pi is that one that extends so far out. So we're going to solve either one of these, and they're going to equal our value here that we're looking for. So we can multiply by our peak voltage of 28, and that gets us 17.8 average voltage. And we'll say VAVG for average. Right? So we know that our RMS should be slightly above our average, and we see that in our 2 values here. And we see that on this diagram here, that the root mean square should be slightly more than the average usually. All right, let us know if you guys have any other questions.